All right, welcome. We're going to go over what is a determinant. And first of all, we have to go over what is a matrix. And this is something that we did back in Algebra 2 when you were solving systems of linear equations. So for instance, if I wanted to have a matrix, let's say my matrix is A. We use capital letters for a matrix. And I am going to have the following numbers, -1, 2, 1, and 4. That is my matrix. What we're learning about today is finding the determinant of matrix. And the determinant, the way we find the determinant or designate it is we put the name of the matrix inside these bars. So this just means the determinant of matrix A. And the way we find that value, we could also put our numbers in here. We take our numbers, and this is going to seem a little bit confusing at first. On this diagonal, I'm going to take -1 times 4, and then I'm going to subtract the numbers on this diagonal. So 2 times 1. And this is going to give me the value. So -1 times 4 is -4. 2 times 1 is 2. We're subtracting that. So my overall value here is -6. -6 is the value of, is the determinant of this matrix. Okay, so let's do another one. Let's have matrix B here. And matrix B I'm going to define as it's 3, 5, -5, -2. So there's my matrix. I want to find the determinant of B. So the determinant, I'm going to take these values, 3, 5, -5, -2. And to find the determinant, we multiply starting from the top left to the bottom right. So that's 3 times -2. And we subtract, okay, make sure you don't forget that we subtract, going in the opposite order. So top right times bottom left. So 5 times a -5. And when we do this, 3 times -2 is -6 minus a -25. So that's going to become a +25 minus 6 gives me a +19. So the determinant of this matrix is 19. And if you go on to take more algebra level courses, like a linear algebra course in college, reason the determinant is used is it helps you find the inverse of this function. It also is going to get used in our vectors, which we will go over in our next class. But for now, we want to be able to find these. So again, to find a determinant of a 2 by 2 matrix, so number of rows by number of columns, is top left times bottom right minus top right times bottom left. And that gives you the determinant. Well, we could have a 3 by 3 matrix. So how do we do a 3 by 3 matrix? Very similar. So if I have matrix C, for instance, and let's define matrix C as -5, -4, 1, -3, 0, 5, -1, 0, 3. So notice that our matrix, each time we're finding the determinant, it does have to be square, same number of rows as columns. So if I want to find the determinant of this, so the determinant of matrix C, it's similar. It's going to feel a little strange though. I'm going to have to add another color. So we're going to start off. We take the first value here, so -5. We're going to multiply. We're going to cover up that column. And now we're going to look right here. 0 times 3 minus, oops, I was using this. So minus 5 times 0. That gives me the first part of this. I then have to subtract, just like up here, we subtract the top here, so -4 times, and again, cover this column. So now I'm going to be taking -3 times 3 minus 5 times -1. And I've run out of room. So that was the leftmost at the top, middle on the top row, and now I need to take the top. So plus 1 times, cover this row, negative 3 times 0 minus 0 times negative 1. And we have to go through and simplify this now. So I've still got a negative 5. 0 times 3 is 0, minus 5 times 0 is 0. So that's just a 0 for that term. Minus a negative 4 is going to give me a positive 4 times negative 9. This is negative 5, and I'm subtracting, so that's positive 5. So that's going to be a positive, negative 9 plus 5 gives me a negative 4 there, plus 1 times 0 minus is just 0. So this term becomes 0. This term is 0, so I end up with just negative 16. Negative 16 is the determinant of C, of matrix C. And again, the way we do that is we take the top leftmost term, cover that column, and then cover that column and the top row, and we just do the same thing we did for a 2 by 2. 0 times 3 minus 5 times 0. That gave us that piece of it. We then take the middle term of the top row, negative 4, and we're going to subtract it. We will always subtract the middle one. So minus the negative 4 times, again, we cover that up, cover the top row, and now we have negative 3 times 3 minus 5 times negative 1. We move to the last value, and we're going to add this one, so plus 1 times, cover that one and cover the top row, negative 3 times 0 minus 0 times negative 1. And that will give us our determinant. I'll do this again, and this time we're going to use letters instead of numbers. For some of them, it might make it a bit easier to see what's going on. Okay, so here is my new matrix. This time I've got some letters in it. So along the top row, I have X, Y, and Z. And then 1, 2, 3, 4, 5, 6. So let's find the determinant of this matrix D. So I take the top row, the leftmost term, X, and that's going to get multiplied by, again, we cover it up. So we cover the top row and the leftmost column. 2 times 6 minus 3 times 5. Minus the middle term on the top row, which is Y, which, again, we covered that and cover the top row. So we're going to have 1 times 6 minus 3 times 4. Plus the last term on the top row, Z, times, cover that, and we've got our 2 by 2 matrix, so 1 times 5 minus 2 times 4. Sorry, I ran out of room right there. And now we still have our X on the outside. And again, that could be a letter, it could be a number. It's whatever is in this position. 2 times 6 is 12 minus 8 minus Y times 6 minus 12. And over here we have plus Z times 5 minus 8. So this one is going to end up 12 minus 8 is 4 times X, so that's 4X. Oops, I added those, look at that. 3 times, sorry about that, negative 3 times 5 is negative 15. So 12 minus 15 is negative 3 times X, so negative 3X. And here we have 6 minus 12, that's a negative 6 times negative Y becomes plus 6Y. 5 minus 8 is negative 3 times Z, so minus 3Z. So I just want you to see that sometimes our determinant, we will still have letters in there. Sometimes when we do it, we just have a number if all our values were numbers to begin with. So let's try one more together, and then you are going to have some practice problems. Okay, so we've got a new matrix, matrix A, and I want to find the determinant. Again, that looks like the absolute value bars with the capital letter inside. That means determinant of this matrix. So we start with the value at the top left, 1 times negative 2 times 4 minus 5 times 4 minus the value in the second column at the top, a 1, and that's going to cover the top row and the middle column, so negative 3 times 4 minus 5 times negative 6, plus the value at the top rightmost value, so negative 2, times, again, cover those up if it makes it easier, negative 3 times 4 minus negative 2 times negative 6. Okay, now we just need to do the arithmetic, and we will have the determinant of matrix A. So I still have a 1 on the outside. Negative 2 times 4 is negative 8. Negative 5 times 4 is negative 20. Minus 1 times negative 12 plus 30. Minus 2 times negative 12. This gives me a positive 12, but I'm subtracting it. There we go. So let's simplify what we have here for my determinant of matrix A. And so negative 8 minus 20 is negative 28. Negative 12 plus 30 is 18, and times negative 1 is negative 18. And negative 12 minus 12 is negative 24. Minus 2, or times a negative 2 is a plus 48. And now we're just going to go through and add those together. So negative 28 minus 18 plus 48. I would add these two together in my head. That gives me 30 minus 28 gives me 2. So my determinant of matrix A is just 2. And again, I'm not going to go into why or how that helps us find inverses of matrices and what that does, but for what we need for the next class, you need to know how to find a determinant. And now if you check back on the Schoology page, you will see some practice problems. Go ahead and practice these so that you're comfortable with the process, and I will do the attendance assignment, and I will see you next class.